This next lesson is an extension of 5.2. This is now graphing proportional relationships. So instead of checking your cross products or simplifying your ratios to determine whether things are proportional, you can also graph them. And the important thing to know about the graph of a proportional relationship, which I would like you to write into your note packet, is that all proportional graphs are straight lines. They must be straight. That cut through the origin. And if you remember, the origin of a graph is your starting point, which is 0, 0. All proportional graphs are straight lines that cut through the origin. So you might have a straight line, but if it does not cut through the origin, then it's absolutely not proportional. It must cut through the origin. So looking at this graph here, right here is where you're looking at your origin. That's where you want it to cut through. That would be your 0, 0. That's your starting off point. Remember that this axis here, your horizontal axis, is your x-axis, and your vertical axis is your y-axis. So my first ordered pair here, 2, 6, would look like this, 2, 6. For x, you would go to the right 2, so from the origin, I'm starting at my blue point, 1, 2 over to the right, and up 1, 2, 3, 4, 5, 6, takes me right there. My next ordered pair, 4, 8, my x and my y, I'm going to go back to my blue dot, and I'm going to go over 4 to the right, 1, 2, 3, 4 to the right, and up 8, 1, 2, 3, 4, 5, 6, 7, 8, takes me to here. And my last one, 6, 10, back to my blue dot, to my origin. I'm going to go right 6, 1, 2, 3, 4, 5, 6, and up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I end up here at the top. The next thing I would want to do is I would get a ruler. I'm going to pull up my straight edge on my smartboard, and I'm going to draw a line that cuts through all of these green points and see if it also cuts through that blue point. So in order for me to draw a line through my points, draw it here, and if I extend it over the axis, you can see that it crosses right here, not where it needs to cross at the origin. Therefore, this graph would be a no. So you can see, yes, it is a straight line, but since it doesn't cut through the origin, it is not proportional. Both things must be true in order for it to be a proportional relationship. If we look at part B, my first ordered pair, 1, 2, make my origin in green this time. I'm going to start at that green dot. I'm going to go right 1 and up 2, which would land me here. My next ordered pair, 2, 4. I'm going back to the origin, and I'm going to go right 2 and up 4, which would take me there. And my last ordered pair, x is 3, y is 6. To graph 3, 6, I go back to my origin. I go right 3 and up 6, 1, 2, 3, 4, 5, 6, mark my point, and then going to grab my straight edge. You're going to grab a ruler. You're going to draw a line through all of the red points and see if you extend it and if it goes through the green. And you can see that this guy is definitely a straight line. It's cutting through where we need it to cut through, that origin. Therefore, this is a yes, that this one is a proportional relationship. So that's what I want you to do on these two practice problems. I want you to go through, I want you to graph each ordered pair, then take a straight edge and see if you can draw a line through all the points. If it cuts through the origin like it did in part B, then yes, it is a proportional relationship. And if it does not cut through the origin, then no, it is not. Now, we've been working with all whole numbers. I want you to take notice of these guys over here. they have some decimals for our y values. So on your y-axis here, since it goes up to 3.5, a good thing to count by here instead of counting by ones like I've been might be to mark these off as each being a half. So that would be a half. This is 1, 1.5, and so on. You're counting by halves there. That will make it easier for you to graph it. So please pause the video, answer those 2 questions, then come back and check your works. The first ordered pair, number 1, we have 1, 3. The second one, 2, 4. X first, Y second. The next one is 3, 5. And the last one, 4, 6. I'm just writing them out so you get used to what an ordered pair looks like. X always comes first, followed by Y. Remember again that X is your horizontal axis and Y is your vertical axis. And you should be starting every time at the origin when you go to graph your points. So the first one, starting at my red dot, I'm going to go right 1 and up 3. Your first point should be there. The second one, 2, 4, I'm going to go right 2 and up 4. Mark my point. The next one, 3, 5, go back to the red dot. Right 3 and up 5. And the last one, 4, 6, starting at the red dot, over 4 and up 6. Grabbing that straight edge or your ruler, starting at the top point, drawing a line through all points, extending through the axis. You can see it clearly does not touch the origin, so this one should have been a no. In the next one, I'm going to go back to continuing to label my y-axis. I should have 2 here, 2.5, 3, 3.5, 4. And the only reason why I'm labeling them is because we're not counting by units here, we're counting by half units. On the x-axis, we can still count by a unit. Our first ordered pair was 1 and 5 tenths. The second one is 3 and 1 and 5 tenths. The third one is 5, 2 and 5 tenths. And the last one is 7 and 3 and 5 tenths. Starting at my origin, to graph 1, 5 tenths, I'm going to go right 1, up 5 tenths. The second one, I will go right 3 and up to 1 and 5 tenths. The next one, I'm going to go right 5, 1, 2, 3, 4, 5, and up to 2 and 5 tenths. And then the last one, I'm going to go right 7, 1, 2, 3, 4, 5, 6, 7, and then up 3 and 5 tenths, marking my point here. Grab that straight edge, starting through the points, drawing a line. Does it cut through the origin? Absolutely it does. So this one is a yes. All right, so the most important thing to remember here, if you are graphing a proportional relationship, it must be a straight line that cuts through the origin. Both things must be true in order for your graph to be showing a proportional relationship. The next part of this extension, interpreting the graph of a proportional relationship. What do each of these points actually mean on the graph? I'm going to move this up out of my way. It says the graph shows that the distance traveled by the Mars rover, Curiosity, is proportional to the time traveled. Interpret each plotted point in the graph. Well, before I even start to interpret it, I'm looking at that graph and I can see that it is a straight line. I can also see that it cut through the origin right here. 0, 0. So that means that it is 100% a proportional relationship. So what is the relationship now we're going to talk about between time in seconds and distance in inches? So starting off with that first point there, 0, 0, the origin, all that means is that in 0 seconds, notice I'm starting with my x-axis, we've traveled 0 inches. The next one, 1 and 1 and 5 tenths, means that in 1 second, the Mars rover traveled 1 and 5 tenths inches. And the last one, 3 and 4 and 5 tenths, would simply mean that in 3 seconds, Mars rover For some reason I can't say that. Traveled 4 5/10 inches. Alright, so you look at what they have on your x-axis and what they have on your y-axis. We're looking at these labels here. Distance and time. So how much time did they travel and how far did they go? Alright, we started with the x in the ordered pair, which represents seconds, followed by y, which represents your distance in inches. So looking at the practice problems, numbers 3 and number 4 are the ones we're going to look at now. Interpret each plot in these proportional relationships. So number 3 we're talking about money, and in number 4 we're talking about hot air balloons. See if you can look at those two graphs, come up with what each point means on each of those graphs, pause the video, and then come back and check your answer. Starting with number 3, we've got 0, 0. This particular 0, 0 means in 0 hours, we are going to make $0. The second one, 1:15, would mean that in 1 hour, 1 hour, you are going to make your earnings $15. Or $15 per hour. This guy would also be a unit rate because we're talking about per hour worked. So every hour you're working, you're earning $15. And the last ordered pair, 460, means in 4 hours, you are going to earn $60. The next one, dealing with hot air balloon, we're looking at seconds and height. So the origin, 0, 0, would represent 0 seconds pass. You didn't ascend anywhere. You're not going any feet. You're still on the ground after 0 seconds. The next one, 1, 5, means that after 1 second, you would be 15 feet off the ground. And the last one, 6:30, means that after 6 seconds, you're now going to be 30 feet off the ground. This one, if we're looking for the unit rate per second, my unit rate would be 15 feet per second. I'm sorry, that wasn't 15, that was 5. It was 1, 5. So 1 second, you would be 5 feet off the ground. That's my mistake. Glad I caught that. That could have been very confusing. All right, so in 1 second, you're 5 feet off the ground, and then in 6 seconds, you're 30 feet off the ground. All right, that's all we're going to go over for the extension problems.